Hi guys, I hope you are all doing well. Let's see today's question. So today's question we have taken it up from the topic of complex numbers, and we are continuing our series of questions on JEE Advanced. So today's question we have taken it up from the year 2020, and in this question we have been told that a complex number Z is present for which RE of Z basically denotes real part of the Z, that is real part of the complex number. And further we have been told that let S be the set of all such complex numbers of Z which satisfy the expression that says Z raised to 4 minus mod of Z raised to 4 is equal to 4I Z squared. So we have been told that the complex numbers which satisfy this expression has a set which consists of all such complex numbers satisfying this expression. So S is the set of all such complex numbers, and further we have been asked to find the minimum value of mod of z1 minus z2 square. So we have to find the minimum value of this entire expression, where we have been told that this z1 and z2 are the complex numbers which belong to this set S, which satisfy this entire expression. And we have been also given two conditions that says real part of this complex number z1, that is first complex number, is positive, and real part of the second complex number z2 is negative. So we have been asked to find the minimum value of this entire expression. Let's see how do we do this. So we have been given four options. A is given to us as 6, B is given to us as 8, C is given to us as 10, and D is given to us as 8. We need to figure out which out of the four options will become the minimum value of this entire expression given to us. First of all, let's simplify this expression so we'll get an understanding what this expression tells us. Now, first thing we know always that a complex number Z is composed of two parts. One is your real part and the other is your imaginary part. This is your real part and this is the imaginary part, which is I. Right? So Z is x plus yi, and if I want to write Z bar, that is nothing but conjugate of the complex number given, which is x minus yi. If I multiply Z and Z bar, I get this x plus yi and x minus yi multiplied. So it is a plus b into a minus b. You get that as a square minus b square. So x square minus yi square. This makes it x square plus y square, because I square is minus 1. So minus into minus makes it plus. Now when I have x square plus y square, I also know that mod of this complex number, mod of z, is given by root of real part, that is x square, plus imaginary part, that is y square. So if I understand this x square plus y square, I can write this as mod of z the whole square, because mod of z is root of x square plus y square. So if I need x square plus y square, I will square both sides. That gives me mod of z square. So what I understand from this expression is z into mod of or conjugate of z. So z into conjugate of z is nothing but mod of z. Now if I write my expression which is given to us, that is z raised to 4 minus mod of z raised to 4 is equal to 4. So instead of z raised to 4, mod of z raised to 4, I can write that as mod of z square, the whole square, is equal to 4I z square. Get this z raised to 4 minus mod of z square. I already know it is z into conjugate of z square is equal to 4I z square. So z square into z square minus z square into conjugate of z square is equal to 4I z square. So I can see from all of them, I can take out z square common. You're left with z square minus z bar square is equal to I z square. So this z square actually gets cancelled from both sides, and you are left with Z square minus conjugate of Z square is equal to 4. Now, if I try to simplify this idea in the next page, Z square minus Z bar square, it is of the form A square minus B square. So you get this as A plus B and A minus B. That is equal to 4. Now, we had the expression with us that said Z is X plus Yi. Conjugate of that Z bar is X minus Y. So if I take the sum of them, it makes it 2x. If I take the difference between them, it makes it yi. So if I write the sum as 2x and the difference as 2yi multiplied for I. So what I get here is this I gets cancelled out. 2 into 2 becomes 4, which gets cancelled out. So what are you left with? Xy is equal to 1. So now you understand that S, which is set of all the complex numbers satisfying the expression z raised to 4 minus mod of z raised to 4 equal to I z square. That expression which I simplify gives me the result being x into y is equal to 1. So all the complex numbers which satisfy this expression also satisfy this result, which is product of the real part into imaginary part being 1. Then they have also told us that Z1 and Z2 are the complex numbers which satisfy this expression. Z1 I can write that as x plus x1 plus I y1. Z2 I can write that as x2 plus I. When these two complex numbers also satisfy this expression, I can write the same result for the two expressions. So I can understand that x1 into y1 is also 1 and x2 into y2 is also 1. So I understand product of the real and imaginary part for the two complex numbers is also equal. So we get this result. Let's keep it as equation 8. Now let's try to simplify our ideas. Before doing that, let's also analyze these two data which is given to us. We have been told that real part of Z1 is positive. Real part of Z1, we know it is X1. So X1 is given to us positive. And since we know X1 into Y1, product of them being 1, 1 is positive. So product of X1 into Y1 is positive. So positive X1 into Y1 is a positive result. So Y1 also becomes positive. I understand from this that Y1 is also. If I analyze the second data given to me, real part of Z2, which is less than 0 given. So X2 is negative, but I again know the product of them is also equal to 1. So this product also is positive. So negative into Y2 is also a positive answer. So I get Y2 becoming positive upon negative. That makes it negative. So I understand Y2 is less than 0. So I have three results with me now. One result was, if I write this, x1 into y1 is 1, x2 into y2 is also 1. We also know x1 and y1 both are positive, x2 and y2 both are. So these are the three results which we have. Now let's try to solve our question given to us. It is asking us to find the minimum value for this entire expression z1 minus z2 in the mod square root. So if I write this expression first, mod of z1 minus z2 the whole square. So mod of z1 is x1 plus iy minus x2 plus I. So here I get this as mod of x1 minus x2 plus I y1 minus y2 in the mod square. So we already know that mod of anything is square root of the real part. So real part in this case x1 minus x2 square, square of the imaginary part, the square of y1 minus y2 square. This whole thing is again square. So square and square root gets cancelled. We get the value of the expression of mod of z1 minus z2, the whole square becoming x1 minus x2 square plus y1 minus. If I expand this idea, I get this is x1 square minus 2x1 x2 plus x2 square plus y1 square minus 2 y1 y2 plus. Now if I expand this entire idea, I can write x1 square minus x1 x2 minus x1 x2. Instead of writing minus 2, I'm splitting it as minus x1 x2 minus x1 x2. We need to consider the signs. That's why we are writing it separately. 2y1 y2 again if I write plus y2. Now I need to find minimum value for this entire expression. So I understand that I need to find minimum value for this entire expression. So we need to figure out the minimum value for this expression which is given to us now. Now if I check the signs for these ideas, we already know that x1 and y1 are positive. So square of x1, this is positive. Square of y1, that's also positive. We also know x2 and y2 both are negative. And both of them are negative. Because x2 is negative, the square of that is again going to turn out positive because negative square is positive. Y2 square is also positive. If I figure out the product here, you get this minus x1 into x2. I can write this as plus x1 into minus x2. x1 is positive, x2 is negative, but if I see the entire product here, that is minus of positive into negative, so the entire product turns out. This entire product also turns out. This entire product also turns out positive. And this entire, because we already know y1 is also positive, but y2 is negative, negative and negative. Since all of these ideas, all of the terms give me positive values, I can apply one idea which we have already studied in previous videos, that arithmetic mean is greater than or equal to. So let's try to find this. Arithmetic mean, if I add all of these terms, plus minus x1 x2 plus minus x1 x2 plus x2 square plus y1 square plus minus y1 plus minus y1 plus y2. So what you are finding here is arithmetic mean, that is sum of all the 8 terms divided by the number of terms is 8. That is greater than or equal to. Here we have for geometric mean nth root. Here since there are 8 terms, we are taking it as 8th root of the product of all the terms. So product of all the terms, if I take out, it becomes x1 into product of, sorry, x1 square into the other term minus x1 into x2. Next term, it is minus x1 into x2 again. Next term, if you multiply, it's x2 square. Next term, if you multiply, you get y1 square. Next term, if you multiply, you have y1 into y2, the negative sign again. Minus y1 into y2 is the next term, and the last term. So you get this, that arithmetic mean is greater than or equal to geometric mean. If I solve this, I get this x1 square minus x1 x2 minus x1 x2 plus x2 square plus y1 square minus y1 into y2 minus y1 into y2 plus y2 square. That's greater than or equal to 8 times and 8th root of this entire expression. Now if I figure out this solving the entire expression, 8th root is nothing but I can write that as raised to the power of 1 by 8. If I try to solve this expression here, I can write x1 square into y1 square as x1 into y1 the whole square. I can also write x2 square into y2 square as x2 into y2. Then further, if I try to simplify this idea, minus into minus becomes plus, this becomes x1 square into x2 square. So I have solved this expression. If I multiply this, minus into minus is again plus, you get y1 square into y2 square. Not minus, because y1 square into y2 square. So now if I try to simplify this idea, I understand this entire expression is greater than or equal to 8 times. I can write this as x1 square and x1 square. So it becomes x1 raised to 4. You get y1 square and y1 square. So y1 raised to 4. x2 raised to 4. Y2 raised to 4. The whole raised to 1. So if I need to figure out this value of the expression which is given to us, we have been given here that x1 square minus x1 into x2 minus x1 into x2 plus x2 square plus y1 square minus y1 into y2 minus y1 into y2 plus y2 square. So we already know now that is greater than or equal to 8 times, and we have this entire expression. I can write this as x1 into y1 the whole raised to 4 into x2 into y2 the whole raised to 4. This is entirely raised to 8th root. That becomes greater than or equal to 8 times. X1 into y1's product, that makes it 1. So 1 raised to 4. X2 into y2 is again 1. So it's 1 raised to 4. The whole raised to 1 by 8. We already know 1 raised to anything is always 1. So 1 raised to 1 by 8 will also end up in 1. So you understand this entire expression is greater than or equal to 8. So if I need to find this, I understand this entire expression is equivalent to mod of z1 minus z2. So I understand this, that mod of z1 minus z2 the whole square is greater than or equal to 8. So if I need to figure out the minimum value for this entire expression, that is, so the minimum value of this entire expression which was asked to us for the complex number, that was the difference of the complex number in the mod and the square of that. Minimum value turns out to become 8. And if I see the option that matches here with the question is, so B is the correct answer for the question given to us. I hope you have understood how to solve this type of questions. So first we figured out z into mod, z into conjugate of z is mod z the whole square. Solve this, we got one idea simplified, that product of the real and imaginary part is 1. When we was said that the two complex numbers also satisfy that, we get the idea that product of the real part of real and the imaginary part of first complex number is 1. Product of second complex numbers, real and imaginary part is also 1. Then we got the idea that imaginary and real part are positive for the first complex number and the real and imaginary part for the second complex number are negative. Just figured out the mod of z1 minus z2 the whole square. It got this entire expression. All of these expressions were turning out positive. So since we had all the 8 positive terms, we can use the idea of arithmetic mean being greater than the geometric mean. We figured out that, we got the value of the expression and we got the minimum value 8. That gives us the correct answer as B. I hope you have understood this type of questions. I'll meet you again tomorrow with some other question from some other topic. We'll continue this our questions of series on JEE Advanced. So please do like, share this with your friends who are also involved in the preparation of JEE Advanced, so they can also take the benefit from these questions which we are solving every day. Also, please do subscribe to my channel. Thank you.